Yeah, ladies and gentlemen, good day. Today we are going to look at thermodynamics, and under this thermodynamics, we are going to look at the following terms: definition of thermodynamics, the origin of heat, reaction, exothermic reaction, endothermic reaction, representation of exothermic and endothermic reaction using graph, different type of reaction of heat reactions, and then heat flow. So without wasting our time, we are now going to look at this term one after the other, and starting with the definition of thermodynamics. What is thermodynamics? Thermodynamics is the study of the energy and the heat associated with chemical reactions or physical transformations. So in this one, it's simple. When we are talking about thermodynamics, it means that the energy or heat that are produced or consumed during the rate of the chemical reaction. So in this case, let's say for example, we have let's say we have A react with B, react with B to produce, let's say, a product P. So A and B are the substrate of the reaction, while P O are the reactant, while P here stands for the product. So now what we need to understand in the thermochemistry is mean that the amount of heat or energy that is consumed by this substrate to produce the products, or the amount of heat that are released by this A and B to produce the product P is what you call thermochemistry. Because remember, when we said chemical reactions, it means when you have reactants converted to produce products, or the product converted back to produce the reactant. So in a process where the reactants are converting to produce a product, or the products are going back to produce the reactant back in the case of reversible reactions. So that amount of heat that absorb or release during that process is what you call thermochemistry. So a chemical reaction may release or absorb energy, as I said. So when in any reactions we have, in all the reactions that we know from our basic secondary school, whenever we have a reaction taking place, so in that reactions, one of these two must happen. Either energy is released or energy is absorbed. And a phase change might do the same, such as in melting and boiling. When we say a phase change, it means that if you have a combustion of the substances from solid to liquid, from liquid to gas, that combustion process, we call it a phase change. Like for example, if we have liquid converting to solids, the process is called freezing. And if we have, let's say, solid is converting to liquid, the process is called melting. So in the process of this melting, boiling, freezing, evaporation, condensation, a heat might also release or absorb. So what I want us to understand in thermochemistry can be in a physical transformations, that is the change of a physical state, solid to liquid or gas, or in a case where we have a chemical reaction. So it means that it can occur both in physical states and also a chemical changes. So that is thermodynamics. So it's a study of heat changes. In other way, you can just see energy changes or heat changes. So And one very important thing that we need to understand when we are talking about thermodynamics in general, thermodynamics is usually happen in all daily life activities, in everyday activities. For example, if you are working, that is if you are moving from one point to another, you are producing ATP, and that ATP are hydrolyzing. And when you hydrolyze that ATP, is usually do some mechanical work, and as a result of that mechanical work, a heat is released, which usually used in maintaining the temperature of the body. So in our everyday activities, we have this. And one very important thing that we need to understand in this thermochemistry is usually involve the study of the microscopic properties, and these microscopic properties include temperature, it includes temperature, it includes pressure, and also volume. It includes the study of volume, heat, and energy. So we need to understand in thermodynamics or in thermochemistry, it usually deals with these microscopic properties, which is temperature, pressure, and volume, as well as heat and energy. And after this, we need to know that in thermochemistry, we also need to look at what are the origin of the heat, the origin of heat. So what we need to understand here is under this origin of heat of reactions, the heat of the reactions is usually happened when or is usually occur, or the heat of the reactions are usually produced in a chemical reactions. And in these chemical reactions, as I said, when the bond or when the chemical reactions are being broken or produce a heat, or the energy is usually released, and when the energy is released, and at the same time and in some of the reactions, the energy will be absorbed. And the energy here we are talking about is heat. So when a chemical reaction will occur, it will release heat or will absorb heat. So we need to understand, because generally in any reactions, there must be release of energy or absorb of energy for the reaction to take place. But in this case, because we are talking about thermochemistry, so in thermochemistry, the heat we are talking about is heat. So the energy or the heat of reactions is usually produced when there is a chemical reaction. And then the next thing that we are going to look at is, so we can get two different types of heat of reaction. So in a reaction, we can have heat release, and we can also have heat absorb. So these are the two different types of heat that we can have when there is a reaction. Then the next thing is look at this. We have something like this. We have the heat absorb. You see, this is A. So A react with B plus heat. So you see, in this reaction, heat is absorbed. That is for A to B, for A and B to react to produce C, heat must be absorbed by this A and B. So that is where we have heat absorb or heat absorb. And whenever we have the heat absorption in a particular reaction, that type of reaction is usually have delta H to be positive. What is the meaning of delta H? Delta H means enthalpy change, that the heat content of the system. We'll talk about them later. But we have to remember that whenever we have a reaction and the heat is absorbed, so that type of reaction is called endothermic reaction, and delta H is usually positive. which is enthalpy of the reaction. Sorry, which is yes, enthalpy of the reaction is always positive. And then the next thing that we are going to look at this reaction. A and B react to produce C, and this C release heat. So you see that heat is released after the reaction. So, and the enthalpy, which is delta H, is negative. So we need to understand whenever there is a reaction, and in that reaction heat is absorbed, that is the reactant, and the reactant of the reaction absorb or consume heat to produce the product. So delta H is said to be positive. And whenever we have the heat release, that is when the reactant produce the product, and at the end of the reaction, the heat is released from the reaction. So delta H is usually negative. Then the next thing that we are going to look at is exothermic reaction. So what is this exothermic reaction? Exothermic reaction, in many reactions, heat is released in the form of heat or light or sound. So these are exothermic reactions. So in a chemical reaction, the amount of heat required to break the whole bond of the reactant is lower than the amount of heat energy or require of energy released for the formation of the bond of the product, and thereby heat is transformed from the system to the surrounding. So it's referred to as exothermic reaction. So in a simple term, in exothermic reaction, the heat or the energy that is needed to break down the whole bond from the reactant is lower than the energy produced after the formation of a new bond in the product. And that is why, because the energy of the product is greater than the energy of the reactant, so that is why heat is usually released after the reaction. And the release of the energy is usually from the system to the surrounding. And I will also, there is also a video that will explain what system is and the surrounding. So then, and when we set a system, let me just give some typical demonstration here. Let's say this is your container. You have a container like this. So if you have, let's say this is where you have your reaction taking place. Maybe you have your A and B here to produce maybe A plus B. You have your A plus B here. Then this A plus B produce your product, let's say C. So now what we are trying to see is, this is a system where the reaction is taking place. So when you said a system is a region where a process is taking place, so whatever is inside this container is our system, but anything outside the container is called surrounding. So that is why we need to understand, if the reaction between A and B produce C and D, and at the end of this reaction a heat is released from this system and outside the surroundings, so the reaction is said to be an exothermic reaction. And why do we have this release of energy from the system to the surrounding? Is because the energy that is required to break down the bond in the oil bond in the reactant is less than the energy that is produced after the formation of a new bond. So that is that for the exothermic reaction. And then the next thing that we are now going to talk about is endothermic reaction. So you see, this is a typical example when we are talking about the exothermic reaction. Look at it, the heat energy required to break the whole bond of the reactant molecule, you see, is less than the heat released for the formation of new bond of the products. And look at it, this is the system, and then this is the surrounding. So we see, observe that the heat is released from this system to the surrounding. That is why we have an arrow pointing this direction. Okay, that is this. And then the next thing that we are going to look at is the representation of exothermic reaction. How did we represent exothermic reaction graphically? So this is it. The reactant, this is the reactant. You see, this is the reactant here, and this is the product. So if you are going to draw it, you will have the reaction pathway, potential energy at the vertical side, and the heat is released. So that is where delta H is negative. So if you are asked to, and one thing that I want us to understand, this is delta H, and delta H always is represented as something like this. Delta H is equal to is usually the summation of the heat of products, summation of the heat of products, summation of the heat of products minus the summation of the heat of reactant, and the summation of the heat of reactant. So we have our reactant here R. So that is the exothermic reaction. So in this case, because the heat energy produced or that produced as a result of the reaction of that product is less than that of the reactant. So that is why after you calculate, you will see that your delta H give you negative. Okay, then